Any good experiment tries to address a question, and that question has to be addressed in a logical fashion. So what we do is we try to make a claim, and then we collect evidence that's going to support that claim. And then we have to describe the reasoning and why we think that evidence supports that claim. So it's claim, evidence, and then reasoning. It's the same pattern with any good argumentative writing. Now let's take a look at this particular lab report. Now this lab report is an example of what you're going to have to do. In fact, I'd like you to try to do something like this, at least walk through this example and write it all out and turn it in so I see that you've worked on it. In the future, you're going to have to start trying to do this on your own. So you have a question and topic or topic that's being addressed. And the question or topic that's being addressed is, what is the percent oxygen composition of air? Now, before any scientist goes and tries to answer a question, they need to have some kind of background knowledge. They have to have some understanding of all the different factors that influence their experimental design, anything that anyone else has already done, any research anyone's done on the particular topic or question. So we call that background. And the background is a summary of all the information that you've gathered from your research. So the background is where you need to write, you need to explain the concepts you're basing your argument on. Remember that a theory is an argument that attempts to explain a phenomenon. So you need to, oh, by the way, a phenomenon is just a happening. So something happens, an apple falls from the tree, or a fish breathes underwater, or you notice that there's oxygen in air, and you wonder what percent of the air is oxygen. So you have this phenomenon, and an argument tries to explain that. And so you need to develop your argument, and what that means is you have to do that background research, that background explanation of what you think is going on. And your background should prepare for that argument, right? So you need to think about all the things that you would need to know in order to answer this question, in order to design an experiment that could answer this question. All right. So a hypothesis is a scientific guess based on your the background information, your background knowledge, a scientific guess as to the answer to the question. Now, we spent a day going over all the basic knowledge, all the basic background information you would need to know to come up with a hypothesis, to guess. So what I wrote here is one possible hypothesis. You could have written many hypotheses using this particular lab setup. But if a sample of the air were trapped in a container that did not allow gas in or out, and we get rid of the oxygen, then the total volume of gas minus the leftover volume of gas is the volume of oxygen in air. And I think you'll understand this a little better as we go along, although we've gone through it, we've described it, we thought about that rationale, that reasoning in class, and we'll continue to through this lab report setup. And I'm breaking this up page by page, and I'm posting the videos one page at a time. That should possibly reduce some of your stress. So one thing you have to think about is this thing called independent variable, and a number of you know what independent variable is. You've covered it in middle school, but an independent variable is the variable that that's changed by you. When you change that variable, when you make it hotter or make it colder, or you increase the time or decrease the time, or you increase the amount of a reactant, like you add more sugar, you add more steel wool, or when you change the variable on purpose, that's the independent variable. So because you're changing it, or it's not, in other words, this variable is not dependent on the other variable. There's only two variables you're looking at. Whenever you're doing an experiment, you're only changing one thing. That thing you're changing is called the independent variable. And in this case, in this experiment, it's time. You're allowing the experiment to run at various lengths of time: 1 day, 2 days, and 3 days. Dependent variable. The dependent variable is what changes because of the time. So after 1 day, something changed. What was it? After 2 days, it changed again. Why is it? What is changing because of time? If everything else is the same, and you're only waiting for something to happen, then your dependent variable is the thing that's changing, and the independent variable is time. You'll notice that time is the classic example of independent variable, because nothing changes time. Time changes on its own, and everything else changes because of time. All right, experimental groups. Experimental groups there's several groups in an experiment, and in this particular experimental group, that's the data that results from you changing the independent variable, right? The experimental group is the one that you're not really quite sure what the answer is going to be. Maybe the volume goes up, maybe the volume goes down, maybe there's no change in the volume. So that experimental group is the group you're interested in looking into. You want to see what's going to happen. In this case, we want to see how much change is going to happen. What is the volume of oxygen in this space, and that represents the volume of oxygen in percentages. Once you do your percent oxygen in the atmosphere. So this is your experimental group, and it has a test tube with steel wool, and we'll see what happens. Your positive control, there is no positive control in this experiment, but your positive control is when something you know is going to happen. So if you want to know if sugar is going to react with fire, will sugar burn with fire? No, that's not a good example. If you're not sure if a substance has sugar, you have a white powder and you're not sure there's sugar in it, and you add, and you want to know if there's sugar in it, and you have an indicator that turns red if there's sugar in this powder, you would add the indicator and see if it turns red. Well, your positive control would be if you took that indicator and put it on something you know is sugar. So you just want to compare. See, these two groups, these two control groups, controls are groups that you want to compare your data, your experimental group to. So you need something that's going to allow you to say, okay, this is what a positive looks like, and my experimental group, my unknown, looks like the positive, so I'm going to call this positive. Now your negative control is the one where you know nothing's going to change. It's not the oxygen, in this case, the oxygen concentration is not changing. And how would you know that? What kind of group? What could you do that would allow you to compare your experimental group to it, so that you can see what no change looks like? Well, what would happen is that you would put one test tube, the experimental group, with the steel wool in the same exact conditions. You put another test tube without steel wool. If we know the chemical reaction of iron and oxygen, that rusting of the iron is going to remove the oxygen from this space, then it should not happen here. If our background knowledge of the chemical reaction and our laboratory setup is all correct, then this should rust and this water level should go up, because there would be less pressure inside the test tube in the experimental group where it has steel wool. It may not go up. Maybe it may go up 20%, may go up 5%, may go up 50%. But whatever it goes up, it should go up based on how much oxygen is used up. Well, how do I know it went up because of that? How do I know that it went up because of that, not because maybe the air pressure increased outside, or maybe there's a leak in the test tube, or maybe the water is absorbing the gas? How do I know that something else is not going on, and it's actually the oxygen being being removed by the chemical reaction with iron? Well, I know that because I can compare it to the same setup. In other words, everything is the same. All the amount of water, the type of water, the test tube, etc., is the same, except this test tube has no steel wool. So if this one goes up, this water level goes up 20%, and this one doesn't, then it's likely that the difference between the two is the steel wool is rusting. So, in other words, the oxygen is being removed. So, a negative control, again, is a way for us to compare our experimental results to the results from the negative control group, so that we can make we can be more certain about our claims. All right, so the negative control would be a test tube without steel wool. The water level should not change. If the water level here goes up by 5, but it goes up here by 10, then I know 5 centimeters of water change was due to some other impact, not the loss of oxygen. So you see, you can use this negative control as a comparison group to really filter out any other confounding factors that could give you false results. So in summary, the question or topic leads us to design an experiment that answers the question. Your background will help you explain why you designed your experiment the way you did and why you think your results say what you think they do. So your background is going to help you with your reasoning. So the topics that were covered here in this page, on this page of the lab report, were the question and topic, the hypothesis in an if-then format. As you saw, it was in an if-then format. Let's make sure we look at that. It says here, if a sample were trapped and did not allow the gas to go through, then this would happen. If this happens, then that happens. It's a very logical format, and it's very testable. You can test it, because if it does happen the way we think it does, then something we're predicting is going to occur. If this does not occur, then the opposite's also true. This can't be true. So if this is true, then this must happen. If this doesn't happen, then this is not true. So that's an if-then statement. Hypotheses are often written that way because it makes for really testable, really nicely testable format. Your experimental design, as we talked about, should include a control group. It should include your independent variable, your dependent variable, and you should have some idea of what you're going to do, how you're going to set up the things you need to set up. Again, how would you do that? You'd have to have some background knowledge. You have to have something to base your design on, that you could say, well, if we do this, then that should happen. And of course, you need your positive and negative control group as part of your experimental design. So that's the first page of the lab report. I hope this helped.